Hi guys, so the first thing I want to chat about are some of my keys to mathematical success. This is, if we think about all the different things that are in Math 104, for instance, and all the different algebra topics that were in Algebra 1, Algebra 2, there's a lot that we're going to cover. And I think there's some set rules that can really help you be successful in a math course. The first is, if you think of math as a set of rules, steps, or algorithms to memorize, math is going to become something that is just impossible to do at some point because there's so many different types of problems and ways to solve them that you're not going to be able to keep them all straight in your mind. So you really need to just take that and get rid of that idea right now. There's another way to think of things, and that is to realize that there are some set mathematical conventions. And what we mean by a mathematical convention is usually notation, a name or some usage that is just agreed upon by mathematicians. So the most quintessential idea of a mathematical convention is something like this. 2 plus 3 times 4. Right? This is one of those questions they would put up all the time on, you see them on like Facebook if you're, something your aunt or uncle shares. Because most of us want to sort of work left to right, but we know that the order of operations tells us we need to deal with multiplication first, and then we can deal with that addition. Now, the order of operations is a mathematical convention. This is just something we agreed upon because as we started making computers and calculators, we needed them all to give the same answer to something typed in like this. So this is not something that makes sense that you can figure out by looking at it. This is just something we all agreed upon and something we do need to memorize, for lack of a better way to handle it. But most everything else, once you've got a couple of conventions under your belt, like the order of operations or what an exponent represents, everything else falls into place. And so I think a lot of students think everything's a convention, everything is something we've agreed upon as mathematicians, and therefore we need to memorize it. But in reality, that's not the case. We can look at something like 2 to the 0 power. Many of you may have memorized that anything to the 0 power is just 1. But this is also something that as long as we know what the convention of an exponent is, we understand some patterns and the real beauty of math that we can show ourselves makes sense. Like what happens if we have 0 factors of 2? Well, there's always that base identity of 1. Or even better, we think about this by looking at what happens as we increase exponents, right? If we think about an exponential function, which is not technically in our review, but makes me happy, so I'm going to talk about it. So as we move, let's ignore the 0, 1, because maybe we haven't agreed upon that yet. We're multiplying by 2, right? We're adding another multiple of 2 each time. So if we had 2 to the 4th, we would just take whatever 2 to the 3rd was, and we'd multiply it by 2 to get 16. Obviously, we could also expand these out with our multiple 2's, right? We could rewrite these things as 2 times 2 times 2 times 2 if we wanted to use the definition, the mathematical convention that is what the exponent represents. But we can also think about then going backwards. To undo all of this, we're multiplying by a half or dividing by 2, right? I'm going to go with times a half because then we're still staying in exponential land because we're multiplying by the same thing. So that is where it makes sense that 2 to the 0 is 1, because if I continue following the pattern as I reduce that number as an exponent, it makes sense that I would end up with 1. And even more so, if I went to the negative exponents, same thing. Now we've got 1/2, and that makes sense as to why our negative exponent takes whatever the heck it was raised to into a denominator. So again, I just sort of want us to think about this idea of there are some mathematical conventions. Obviously, what an exponent represents is one of them. The order of operations is another. But then there are a lot of other pieces that we shouldn't take as conventions, that we should see why it makes sense that they are the way they are, or figure out what the proof is behind them. So the second rule is noting the difference between an expression and an equation and what we can do differently in each situation. So an expression is just any mathematical notation that doesn't have an equals or an inequality symbol. So a very simple example would be something like 3x plus 12. That's an expression. We're going to see a lot of expressions in trig that have trig functions. So something like the sine of 3x plus 12 would still be an expression. Right? Those are both expressions. Versus an equation is something where we have something like 3x plus 12 is equal to 15. Or sine of 3x plus 12 is equal to 1. Something like that. Those are both equations. And so the way we handle both of these is very different. And the things we can do with both of these are very different. So for an expression, these are things that we can either evaluate or rewrite an equivalent expression. So that's really what we can do. And that really limits us, right? Evaluate is straightforward. What is 3x plus 2 when x is equal to 1? Well, we're just going to take the x in that particular expression and replace it with 1. Now I can evaluate that thing, and it's 15. That's simple. Rewriting as an equivalent expression, there's a lot of different ways that that can go. We can take something like 3x plus 12, and we can rewrite it as a factored form, so we could take a 3 out of both terms. That's one of the key things that you need to know to be successful in trig is how to factor. We could actually make it more clear what's happening. We could make this as just 3 times x plus 12. That's the exact same thing, but it's more clear than the coefficient. We could even go ahead and make this 3 over 1, right? So that way if we're thinking of this as like a slope and an intercept of a line, so if this was y is equal to, might be helpful to write it that way because now we have a slope that has a change in x, or a change in y over a change in x, right? So we can actually say we're going to go up 3 over 1 if we were to graph this. So there are a lot of ways that we can rewrite this. We're going to see more complicated methods like completing the square, but the main thing here is that it needs to be the same. We can factor, we can divide by 1, we can multiply by 1, we can add 0. One thing math people like to do is to take something like this and rewrite it as like 3x plus 3 plus 9. You're saying, why the heck would you do that? Well, because then maybe you're factoring out the 3 from this and leaving that plus 9 hanging off the back, right? There might be some situation where that makes sense to do. So the difference here is we're taking the 12 and we're splitting it up. We might add or subtract the same thing to each side, add and subtract the same value without, that doesn't change the problem. So this is something we're going to be doing a lot in trig, especially when we start talking about how to deal with trig identities. In that case, we're going to have an expression on either side of an equation. So it will be an equation, but we're going to only manipulate one side of that equation. And so we're going to treat that equation, that one side, like an expression, and all we can do are these same sort of rules. Factor, rewrite as equivalent pieces, divide by 1, so forth and so on. So an equation, right, this is much simpler. These, we could just need to make sure that we're being fair. And typically, I've run out of my space. I know that 15's off the screen. Typically, we just need to make sure we're doing the same thing to both sides. That's not truly everything. Something like squaring both sides takes away whether something was positive or negative. Square rooting both sides kind of has that same issue. So we need to think a little bit harder about what's happening to both sides. But typically, addition, subtraction, all of those things are good. And this is probably where students get the most algorithms back in an Algebra 2, Algebra 1 class. All these different ways to solve a bunch of different equations. And it all comes down to one idea, which is we need to isolate our variable. And in order to isolate our variable, we need to undo all the things that are happening to it. So in this question, we can see there's a 3 being multiplied and a 2 being added. And then we just need to peel away the pieces in a way that makes sense where we're not running into any trouble or breaking that order of operations. And when we're solving, we go in the reverse order of the order of operations. So, getting rid of a 12, leaving us with 3x is equal to 3, and then dividing by that 3, and finally getting to our answer of x is equal to 1. So same thing is going to happen here, except for we recognize x is trapped within an entire thing called sine, right? This function, this trig function. And so our first step is going to be, well, order of operations says the very last thing we're going to do after everything in the inside of this parentheses is deal with that sine function. That's the first thing we're going to have to get rid of. So we need to figure out how to undo a sine function, which will be something we learn later in the course.